Assalamualaikum and hi everyone. We are group 4 from class 22 and in today's video, we will be presenting about back titration, ensuring aspirin purity in pharmaceuticals. First and foremost, this is our group members.
Assalamualaikum and hi everyone. Today I'm going to talk about back titration. So first thing first, what is back titration? Back titration is a titration where the concentration of the electrolyte determined by reacting it with a known amount of excess reagent. The remaining excess reagent is then titrated with another second reagent. So let's move into the next part. Back titration is applied when the reaction is too slow or the acid or base in an insoluble salt. It also applied when one of the reactants is a volatile, such as ammonia. Other than that, back titration is applied when the reaction involves between weak acid or weak base. And it also applied when sharp endpoint is difficult to obtain.
For theory, back titration is an effective method to determine the purity of aspirin in a pharmaceutical product. The process involves reacting a known mass of aspirin with an excess amount of sodium hydroxide. This reaction converts the aspirin into sodium acetylicate and water, ensuring all aspirin react. Next, the excess now is titrated with a standard hydrochloric acid solution. By calculating the initial mole of now added and subtracting the mole of now that reacted with HCl, we can determine the mole of now that reacted with aspirin. Since the reaction between now and aspirin is in a 1:1 molar ratio, the mole of now that reacted corresponds to the mole of aspirin in the sample. Using the molar mass of aspirin, we convert this value to mass and calculate the purity by comparing the mass of aspirin obtained to the original sample mass. Expressed as a percentage, this indirect titration method is valuable for accurately measuring the purity of aspirin, especially when direct titration is impractical.
My name is Lina Wajia and I will explain methodology on this slide. Commercial aspirin tablets typically do not contain 100% pure acetyl salicylic acid. They often include impurities like acetic or salicylic acid. Binders, which are in a substance, are also added to prevent tablets from breaking. The presence of binder indicate the tablets are not completely pure. Aspirin, being an aromatic compound, has a carboxylic acid and an ester group. This weak acid that's slightly soluble in water and acidic solution. Exposure to moisture can lead to hydrolysis, breaking down salicylic acid and acetic acid. Why is back titration preferred over direct titration? They have 6 factors. First, limited solubility. Second, presence of interfering substance. 3, accuracy in determining endpoint. 4th, flexibility and control over reaction. 5, handling over weak acid or bases. And the last one is reduced sensitivity to endpoint detection. For objective, to determine the purity of an aspirin sample using the back titration method. This involves reacting the aspirin with excess hydrochloric acid, followed by titrating the unreacted acid with standardized sodium hydroxide. The purity of aspirin is calculated based on the amount of acid that react with the aspirin. For apparatus, volumetric flask 1 250 ml and 2 100 ml, Richter stand 3 conical flask 250 ml, 25 ml pipette, puree, wake, boat, bottle paper, filter thinner, dropper, 1 m, 8AOH, 25 ml, phenolphthalein, aspirin tablet,
0.25 grams of aspirin sample,
and 0.1 m HCl, which is 10.5 ml. Back titration is an effective analytical technique for determining the amount of aspirin in a tablet when direct titration is not feasible. This experiment involves preparing a 0.1 m hydrochloric acid solution by diluting concentrated hydrochloric acid, using it to react with a known excess amount of hydrochloric acid with the aspirin in the sample. The aspirin tablet is first crushed and dissolved in the hydrochloric acid solution, ensuring complete reaction. After the reaction, the excess hydrochloric acid is titrated with a 0.1 m sodium hydroxide solution using phenolphthalein as indicator. The volume of sodium hydroxide used is required to calculate the amount of unreacted hydrochloric acid, which is then subtracted from the initial amount to determine the hydrochloric acid that reacted with aspirin. By applying stoichiometric principle, the amount of aspirin in the tablet can be accurately determined. Second, preparation of sodium hydroxide. The process begins with the preparation of 0.1 m sodium hydroxide solution. This involves accurately weigh 35 ml of solid sodium hydroxide, dissolving it in distilled water, and dilute to 1 liter in a volumetric flask, ensuring complete dissolution and homogeneity. The aspirin tablet is then weighed, crushed into a fine powder, and dissolved in a known excess volume of 0.1 hydrochloric acid. The mixture is heated gently to ensure configuration and then cooled. The excess hydrochloric acid in the solution is saturated with the prepared sodium hydroxide solution using phenolphthalein as indicator. The volume of sodium hydroxide used is recorded, and the moles of unreacted hydrochloric acid are calculated by subtracting the moles of sodium hydroxide used from the initial mole of hydrochloric acid added. Using the stoichiometry of the reaction between aspirin and hydrochloric acid, the amount of aspirin in the tablet is determined. This is procedure that we must follow during the experiment. Firstly, a definite number of aspirin tablets was weighed accurately. 2 or 3 tablet weight no more than 1.5 gram. The brand name, the manufacturer's name, and percent content mass of the active ingredient in the tablet was recorded. Second, the aspirin tablet was weighed accurately in a weigh paper, and the tablets was transferred into a 250 ml conical flask. Third, 35 ml used tablet. 1 ml solution was added and 35 ml of water to the tablet. This mixture was heated until it boils for about 10 minutes in order to hydrolyze the aspirin. Fourth, the solution was cooled in a room temperature. Then, 250 ml volumetric flask was transferred quantitatively. The solution was titrated to the mark carefully using dropper when the level close to the calibration mark. Back titration procedure. First, 0.1030 gram of aspirin solution was prepared into a 250 ml liquid flask. Second, 1 or 2 drops of phenolphthalein indicator was added. Third, the aspirin solution was titrated in the 250 ml conical flask with the diluted 0.1 m HCl solution from urate slowly while shaking the flask until indicator changes color. Methylene pink to colorless. The reading was recorded at the end point of the titration. Fourth, 2 or 3 times was repeated, and all the readings was recorded in a table.
Moving to the next part, here how can we calculate the purity of aspirin? Before we start to do the calculation, we have to list down all the information given. Next, for the first step, we have to calculate the moles of sodium hydroxide and hydrochloric acid used. The formula of moles is N equals to MV, which is molarity times volume, but make sure the volume is in liter. For the second step, we have to calculate the moles of excess sodium hydroxide. How can we get the value? We have to minus the moles used in sodium hydroxide with moles used in hydrochloric acid. Then we will get the answer, which is 1.45 times 10 to the power of negative 3 moles. For the next step, we have to calculate the moles of aspirin. We can get it by looking at the balanced chemical equation. Then we will get the ratio, which is 1 moles of sodium hydroxide is equals to 1 moles of aspirin. Therefore, the mole of aspirin is 1.45 times 10 to the power of negative 3 moles also. For the fourth step, we have to calculate the pure mass of aspirin. But before that, we have to find the molar mass of aspirin based on its chemical formula. Then we will get 180 gram per moles. Now we can calculate the mass of aspirin, which is molar mass times moles. Then we will get 0.261 gram. So here we come to the last part of the calculation, which is now we can find the purity of the aspirin after we got all the value. The formula is the mass of pure aspirin divided by mass of sample multiplied by 100. Then we will get the answer 104.4%.
In conclusion, the calculation performed on the aspirin sample indicates an approximate ASA content of 104%. However, aspirin tablets must contain not less than 95% and not more than 105% of the labeled amount of CHM256 This suggests that there were substantial assumptions or experimental flaws that resulted in an overestimation. Finding and reducing titration mistakes is essential to getting accurate findings. Titration plays a crucial role in quality control in the pharmaceutical sector by guaranteeing the safety, effectiveness, and also compliance with regulations of pharmaceuticals. And this is our reference. finally, we have reached to the end of our presentation. Thank you so much for lending your ears, and that's all from us. Thank you.